Hey, I'm Elad. Today we'll talk about OIDC tokens and how they can be utilized in CI/CD pipelines. I'm a security researcher at SciCode, mainly focusing on supply chain security and web application security. We'll start with the problem with using secrets and tokens across the software development lifecycle. We'll show how OIDC works and how we can utilize it for keyless authentication. Then we will compare between traditional authentication to OIDC authentication, followed by a real-world example. So let's start with the problem. Modern SDLCs. Modern SDLCs has many components. The developers that are creating and pushing new code, the SCM systems that are storing the actual code. Then we have the CI/CD systems. Systems like Azure Pipelines, GitLab CI, Jenkins, and more will have triggers that define automated procedures such as on a new issue, on a new tag, on a new pull request, test, deploy, and build. Then it will communicate with the artifact registries that will create a PyP package, npm, or Docker image that are the final artifact. Then the CI/CD systems will also communicate with the cloud infrastructure to deploy new code and new images to the production environment. So we used a GitHub search bar to filter for GitHub Actions workflow files and see how GitHub Actions are communicating with third-party sources. We can see that using secrets are mainly widespread. Secrets such as AWS secrets, GCP, PyP are very common. And it's not as bad as storing hard-coded secrets and saving the actual secrets in the code. But we can see they are mainly widespread, and we can try to see if we can do something better and not using secrets at all. So traditional authentication is causing a problem. When storing secrets and access tokens, we have no visibility on who has access to them and if they got exfiltrated or not, causing the identity management problem to become to secret management problem. Meaning, if a secret got exfiltrated, the identity has to revoke that token and make sure no malicious activities is made with that token. After talking on secrets and access tokens that are long-lived, meaning we can use them many times for a long period of times, and we have no control on who is using them, who has access to them, and we have no idea if they have been exfiltrated or not. Let's move to OpenID Connect. OpenID Connect tokens allows two third parties to communicate and authorize each other. They are JWTs and allows keyless authentication using short-lived tokens instead long-lived tokens that we talked before. Let's see how the structure of our OpenID Connect tokens are built. Firstly, we have the standard user claims, the info claims, meaning each OpenID Connect will have them. We have the issuer, the subject, and many other details that will be in each JWT token. The most important part that those JWT are signed, meaning they can't be tampered. So the data inside them is trusted and can be verified by the other third party. Let's move to the custom claims. After looking at the standard claims, we have some custom claims that can be changed between different identity providers, meaning each third party has its own capabilities and features. Meaning, if we are talking about GitHub, we will want to have the repository name, what job ID ran and got the OIDC token. Will have the specific branch name, and that is where OIDC is coming into CI/CD. So let's see how it worked in CI/CD systems. So firstly, we have a new job, right? we have a build pipeline that is being triggered and creating a job. Then the job is pulling a request token, meaning is asking from the GitHub, for example, identity provider, for an OIDC token. In return, the identity provider and the CI system is returning a JWT, meaning it returns an signed OIDC token with the details of the CI systems. It will contain the repository name, the branch name, and other details we saw before. Then, using that OIDC that is valid for a short period of time, it will authenticate to different platforms that also support OIDC authentication. Platforms such as GCP, PyPI, and Azure. When getting that JWT token, it will try to verify that JWT against the CI identity provider, meaning the two third parties will communicate between each other and will try to verify if the JWT has a valid signature or that he is being tampered in the way. Then, after verifying the JWT, it will return a short-lived token, meaning it is a token that is valid for a short period of time. In most times, it will be valid for only this specific run, meaning it is valid for 5 minutes, 10 minutes. It can be changed from third party to other third party. And then, after getting the short-lived token, the CI will authenticate back to the platform and will have an access, meaning moving from the traditional authentication that we used long-lived tokens, we used a secret in the CI job to authenticate straight to PyPI. Now we are using a different approach, a short-lived approach. So we are authenticating to the third party using a short-lived token and not a long-lived one. So let's see a real-world example and compare between traditional authentication to OpenID Connect authentication. We'll see how we can utilize GitHub and CircleCI pipelines, meaning with GitHub Actions and CircleCI, to authenticate to PyPI using long-lived credentials and short-lived ones. Let's start with GitHub. We have a GitHub workflow file that will check out the repository, will set up Python with a specific version, then we'll build the package and we'll publish it. Here we are using a PyPI token that is a long-lived token. It is stored in GitHub secret manager, and during runtime it retrieves that token and using it to authenticate to PyPI. The same thing is happening with CircleCI. We are building the package in the same manner and then publishing it to PyPI with the same PyPI token. And using secrets and long-lived credentials, we can complete that task pretty straightforward and without exposing any credentials. So what's wrong? We are not exposing any secrets and we publishing the PyPI package. And what's the big deal? So recent attacks shows us that even we have secrets that are stored in the most secure secret manager, if a supply chain attack exfiltrates that secrets from the build process, we will need to rotate them and change all the secrets after the exfiltration. And after the CircleCI breach, the best practice was to switch to OIDC tokens. The same with Codecov breach that injected pipelines with a malicious command that exfiltrated secrets from the build, meaning every code user, every customer had to change and rotate all his secrets and all his long-lived credentials. And let's see an example for that scenario, and such scenario of a supply chain attack. Let's look on that simple action. We have a new action that with the name of new issue. Its trigger is a new issue, meaning it will be run on each and every new issue that every user can open. Then it will check out the repository and will check the issue title and check if it starts with the CM letters. And if not, it will print an echo title is not starting with a CM, existing title is, and then the title that the user selected. So let's see how that simple workflow can lead to a much bigger supply chain attack. So some issue titles can look like this, a legitimate issue title. Some of them could be something like that. Some of them could be something like that. But some issue titles could look like that. And that issue will create a pipeline injection, meaning it will compromise the pipeline and will inject a malicious code into the pipeline and will exfiltrate all the build secrets. And an attacker will get all those build secrets and will be able to use them and exfiltrate them. And because of they are long-lived and they are not a short-lived ones, meaning attackers can use them more than one time. They a lot of time has no expiration period, and we will have no idea that those tokens even been exfiltrated or that they are being used by malicious threat actors. So let's see the same approach with OIDC, OpenID Connect. Using OIDC, we will ditch the long-lived keys and use the trust between identities providers and will have short-lived keys instead of the long-lived ones. The workflow stays the same instead of two parts. We'll have a permissions section that will have to specify in order to create a new OIDC token. And then we'll ditch the long-lived token we had before in the actual publishing pipeline. Then we'll need to configure a new publisher in Pipey, meaning we'll need to specify the repository name, the owner name, the workflow file. In order to Pipey will be able to verify the specific OIDC custom claims against the OIDC we're generating from our pipeline. After verifying that the owner matches the owner inside the OIDC token, and such as the repository name and workflow, we will generate a short-lived token and will send back to the CI job. So, is it good enough? We have no long-lived keys, where the identity management is no longer a secret management problem, meaning we don't have to worry about where are we storing the secret, if they got exfiltrated, because they are temporary secrets and not long-lived ones. But what are we doing against a malicious maintainer, meaning a malicious user that has a push permissions to the repository, and that will be able to trigger that pipeline and push malicious artifacts? So in this case, we can use GitHub environments. GitHub environments let us to specify some rules that will need to be accepted and passed before the actual GitHub pipeline will be passed. And we can use the Pipey environment section to specify that we are accepting only OIDC tokens from specific environments. So let's see how it works. All we need to do is adding an environment tag inside our GitHub action. And let's see it in action. In this demo, we have a PyP package in third version. We'll specify the owner, in this case is Cycod Labs, the repository name, PackagingCon OIDC, and we'll have the build file that on every push, on every new tag, it will release a new package. And we are also configuring a release name, a release environment, meaning we'll accept, as we said before, OIDC tokens that will have the claim of environment release. So in that release, we are requiring a specific user to approve our GitHub action run. So let's see it in action. We'll go to create a new tag, 1.0.0, and we'll publish a release. Then a new GitHub action will be triggered. Remember that for now we are executing that action without an environment tag, meaning we are not currently in the release environment. And let's see what happens. When sending the OIDC token, that OIDC token has no environment tag of release, and PyP refuses to accept that OIDC token because the OIDC claims are not matching to the ones we configured. Now, let's set up the environment tag. Environment with a specific name. We set up the environment to be a release. And let's try to trigger the action again. And in order to trigger that action, that action will have to pass all the rules that we configured in that environment. In this case, we configured that a specific user has to approve our GitHub actions. And as we see, a user needs to approve our action, and until he approves, we have to wait, and the action will not be executed. After he approves the pipeline, then the pipeline will be executed. And now, in different manner from last time, the OIDC token will be generated with the environment, the right environment input, and PyP will accept that OIDC token, will return the action with a valid short-lived token, and the new version of that package will be uploaded to PyP without any short-lived tokens and with protecting from a malicious maintainer. So, by talking about GitHub action and supporting with PyP, but CircleCI is not supporting, PyP is not supporting CircleCI authentication yet. So, are we continuing with long-lived tokens, or we have any other way? We have other way. We can use OIDC authentication to authenticate to different secret managers that already supports OIDC, such as GCP, AWS, or Azure. Using that, we will be able to authenticate to a secret manager of GCP, for example, using OIDC, and pull the PyP token from the GCP secret manager. And then, after retrieving the runtime the PyP token, we can use it to authenticate to PyP. We can utilize OIDC for authenticating with PyPI, even that PyPI is not supporting yet for OIDC from CircleCI. Okay, to sum up, let's see what we talked about today. Firstly, we talked about what is OIDC, OpenID Connect, and how we can leverage it in CI/CD systems, such as two third parties, like say GitHub or PyPI. Then, we talked about the difference between a traditional authentication, a long-lived authentication, to OIDC, short-lived ones, and how OIDC authentication can help us against supply chain attacks and pipeline injections and other recent attacks that targeted build pipelines. Then we showed real-world examples of how we can utilize GitHub Actions and CircleCI to publish a new package in PyPI using OIDC. That is all for today. Thank you very much.